Hello and welcome to the walking talking topic on tree diagrams, question number 4 with me, Mr. Barton. A bag contains 4 reds and 4 yellows. 3 counters are picked from the bag at random without being replaced. Find the probability that the 3 counters picked are the same colour. Now, I'm going to go for something a little bit different here. I've used tree diagrams in each of the previous questions. I'm going to show you how you can do this one without tree diagrams if you want. But if you feel more comfortable doing a tree diagram, just draw one in the space below here on the worksheet and just see if you get the same answer as me. But I'm going to show you how you can kind of picture a tree diagram in your head. So, all there are 4 reds and 4 yellows. Find the probability that 3 counters picked are the same colour. And notice, again, this key word here, they are not being put back in. So the probabilities are going to change each time. So, let's try the probability of getting a red, followed by a red, followed by a red. Now let's see if we can visualise a tree diagram in our head here. What's the probability that that first pick is red? Well, there are 4 reds, and if there's 4 reds and 4 yellows, there's got to be 8 counters. Now, when we move across a tree diagram, we're going to multiply. So let's move on to our second branch now. Imagine a red's come out of the first branch. So the red has been picked first. You've got a red in your hand. How many reds are there for your second pick? Well, if a red's in your hand, there's only 3 reds. And if you've got a red in your hand, then there's 1 less counter or 1 fewer counter. So you're down to 7. And what about that third branch of your tree diagram? You've now got 2 reds you've picked out, a red and a red. So if there was 4 reds to begin with, there's only 2 possible reds that you can have left to choose. How many counters have you got? Well, you've picked 2 out, so there's only 6 left in. So that is going to be your probability of a red, and a red. And as I say, it's like if you did picture your tree diagram, I won't draw the full thing, but it's just that top branch there. It's a red, followed by a red, followed by a red. 4 eighths, 3 sevenths, 2 sixths. If you times them together, now flipping heck, I'm going to assume that this bit's a calculator because I haven't had much sleep last night and I'm struggling with 8 times 7 times 6. So that's going to be 336. What about my top bit? 4 times 3, I'm alright at this. 12 times 2, 24. Okay, I'm not going to simplify. No point simplifying at this stage. Now, what's the probability of them being the same colour if it's yellow, yellow, yellow? Well, this is good news. You're going to like this because there's 4 yellows out of 8. If your first pick's yellow, then there are only going to be 3 yellows out of 7. And if your second pick was yellow, then for your third one, there's only going to be 2 out of 6. That's going to be exactly the same, 24 out of 336. And all you've got to do is make sure you don't make a horrendous mistake here. So we're just going to add those different possibilities together. 24 and 24 is 48. And remember, you've got 24 of something plus 24 of something means you've got 48 of the same thing. Do not flip and start adding your denominators. You can simplify it if you like, but I'm just going to leave it at that.